Okay, these notes are for section P.6 in rational expressions. And we're reviewing rational expressions from Algebra 2 because we're going to use them through this course. And most students find these not difficult. You just have to be very diligent at checking each step along the way. First of all, a rational expression is just a quotient of two polynomials, so it's a fraction. So there's two examples there. 3x over x plus 2, and another example is x squared plus 5 in the numerator, x minus 7 in the denominator. That's all the rational expression is a fraction. One of the things we're going to focus on are excluded values. What we're looking for is we don't want a denominator to ever be 0. So when you have a variable in the denominator, you want to find out what makes that denominator equal to 0, what value for the variable. So the first example I have is 3x minus 1 divided by x plus 5. I don't care about my numerator, I'm just looking at my denominator. The way I figure it out is I set the denominator equal to 0, but then I put a line through the equal sign because I want to say the denominator cannot equal 0. So x plus 5 cannot equal 0, and when I subtract 5 from both sides, I get x equals negative 5. The other example I have is 1 over x minus 2. So I want to set the denominator not equal to 0, and I solve for the variable. So I get x cannot equal 2. And then we're going to continue to practice this. Here's a more complicated one. I have x plus 1 in the numerator, x plus 1 in the denominator, and 2x minus 7 in the denominator. This is already in factored form, which makes it easier. The numerator I don't care about. I'm not simplifying, I'm just looking for excluded values. So I set each factor not equal to 0, and I solve each one. So the first one, I get x cannot equal negative 1. And the second factor, I get x cannot equal 7 over 2. I tend to use fractions. You could use decimals, but I don't tend to pick up a calculator that often, and so fractions tend to be easier for me. And the last example I have on excluded values, this is not in factored form, so I'm going to go ahead and factor the denominator. And once again, I don't care what's in the numerator, I'm just writing it down as a factor, but I'm not worried about it. Then I set each factor in the denominator not equal to 0, solve each one, and I get x cannot equal 1/2, x cannot equal negative 1/2. And you're welcome, there's other ways to do this, you're welcome to write x cannot equal plus or minus 1/2. Okay. Move this up. Then we're going to actually simplify rational expressions. So we're just going to reduce the expression completely. And I'm going to show you the way that I teach it. And there are other ways to do it that are correct. You don't have to change the way you do it. I'm just reviewing this with you. So my first example, it's just 3x squared y in the numerator, 15x y to the 4th in denominator. And you did these in Algebra 1 and Algebra 2. So the way I teach it first is I break up. I have my numbers first, then I have my variables, and I have my other variable. And then I can also break this apart even further into factors. And this is probably how you were first taught to do this. 15 I break up 3 times 5, and I have a common factor in the numerator, which is a 3, and the denominator, and you can see I've crossed them off in pink. Then I did the same thing with the x's. X squared is the same thing as saying x multiplied by x. I can get rid of one each factor here. Y to the 4th is y 4 times multiplied, so I get rid of 1 for 1. I have to move this up a little bit further. And then I just reduce it. So I have 1x in the numerator, a 5 in the denominator, and a y cubed. And then I look at my excluded values. I don't want x to equal 0, and I don't want y to equal 0. My next example, I have x squared plus 7x plus 12 over 3x plus 9. and I'm going to need to factor this. And this is usually where the difficulty lies for students is the factoring. You have to do the factoring correct or the whole problem gets to be wrong. So my numerator factors into x plus 4 and x plus 3. My denominator factors GCF. I have a 3 and an x plus 3. X plus 3 is a common factor in the numerator and in the denominator. So I cross those both off and I write what's left. I have x plus 4 divided by 3, and I know x cannot equal negative 3. And once again, remember, we're only looking at the denominator for excluded values. On the back side of my notes, I'm going to go through multiplying rational expressions. And I'm going to go a little bit quicker, but you can pause this at any time and rewind it to go through it. So in multiplying, you're just going to multiply numerator times numerator, denominator times denominator. I've broken mine up into factors first. So the 3x and the 7, and then 14 is 2 times 7, and then y. 9 is 3 times 3, and then x and x. And what this does is before I multiply, I can actually reduce some of my factors. Some of you may be comfortable multiplying first, then reducing, and it doesn't matter which order you do it. This is just the way that I choose to. So when I get rid of all my common terms, I'm left with 2y divided by 3x. And the only variable in the denominators is x, so I know x cannot equal 0. My next example, this one has got some factoring that needs to happen, so that's my first step. I factor my numerator, factor my denominator. X plus 1 does not factor, and I factor my denominator. Then I go ahead, anything that's the same, 1 in the numerator, 1 in the denominator, so this x plus 1 and this x plus 1 are the same, I crossed them off. This x minus 2 and this x minus 2 is the same, so I've crossed them off. And I write whatever's left, everything in the numerator that's left is 2. Everything that's left in the denominator is the x minus 7 and the x plus 2. I'm not going to multiply them back together. You may if you want to, but it's a wasted step. It's usually left in this form. And then I make sure I look at my denominator once I have factored to figure out what x cannot equal. We're going to divide rational expressions now. The process of dividing has got one extra step in it than multiplying. So the first thing I want to do is I want to make it a multiplication problem. And the way you do that, if you're dividing a fraction by another fraction, you flip the second fraction, and then it becomes a multiplication. So then once I flip it, I've written it down in the factors. I've got all the factors broken out. And you don't have to do this. If you see it before doing this, you're welcome to go right from this first step to this last one. And I reduce everything. And I state my excluded values. On this example, I have some factoring I need to do. But the first thing I'm going to do is I'm going to flip the second fraction. It has to be the second fraction. You cannot flip the first fraction. So I'm going to flip the second fraction. It then becomes a multiplication problem. I factor everything that's factorable, and then I start crossing off any like terms. And then I simplify. So I've multiplied straight across. The only thing left in the numerator is a 12x. In the denominator, I have a 7, and I have an x plus 1. And my excluded values. And I would be very careful. I do caution people, some of the people that make mistakes are the ones who cannot follow their handwriting, or they've got too much going on, or they don't follow it in a pattern. I like the different colors. It makes it easier for me. Don't erase things. Actually cross them off so that if you've made a mistake, you can go back and find it. But write as neatly as possible, and you're less likely to make a mistake. The next thing we're going to do with rational expressions are adding and subtracting. This one takes a little bit more work. And I know, like when you're in school, you learn how to add and subtract numbers first, then multiply and divide. But in rational expressions, it's easier to multiply and divide than it is to add and subtract. So in adding and subtracting, you have to have a least common denominator. And there's different ways to be taught this also, so I'll go through both ways. My first example, it's not a rational expression, it's just a number, but I like to go back to how you were taught fractions when you first were taught fractions. I'm looking at the fraction 3/4, and I want to add to that the fraction 2/5. So my least common denominator is going to be 20. It's the smallest number that I can make them both become using multiplication. So that means if I want a 20 in the denominator here, I have to multiply by 5. But if I multiply by 5 in the denominator, I have to multiply by 5 in the numerator. I can multiply anything by 1, and it stays the same. It just looks differently. So here, I'm going to multiply the 5 by 4. So if I multiply the 5 by 4 to get a 20, I have to multiply the numerator by 4. So when I multiply, I get 15 over 20 plus 8 over 20. Now that I have a common denominator, I can add the numerator. So 15 plus 8 is 23 over 20. And this one's easy to check in a calculator. The next example now has variables, and each one of these gets a little bit more complicated. There's no plus or minus signs, no factoring that needs to be done, but I have, in this denominator I have a 3x, this one I have a 6x. I want to make a common denominator 6x. So that means what I have to do, I have to multiply 3x by 2. So if I multiply 3x by 2, I have to multiply 5 by 2. So that's where I get 10 over 6x minus 1 over 6x. And if I have 10 minus 1, I get 9 over 6x. But 9 over 6 does reduce to 3 over 2, so I'm reducing it. So x cannot equal 0. The next example I have, x minus 3 is my denominator. It's common for both of them. So in this case, I take a little bit shorter step. Since the denominator is already the same, I could just add 2 plus 5 over x minus 3. There's only thing I could do is add 2 and the 5, and I know that x cannot equal 3. My last example, no, it's not my last, I've got 2 examples. This one, the common denominator in this case is going to be x plus 1 multiplied by x minus 5. I cannot just subtract 6 from here and add anything here. You have to get your least common denominator by multiplying. So once again, I write down the first fraction and I'm multiplying by, minus my second fraction and then what I'm multiplying by. And this is me, this is how I do this. I then write it in one line, and most students don't do this, but this is where a mistake is made if you don't do this. I'm multiplying 7 times the x minus 5, and then this is subtracting, so it's a negative 2 multiplied by the x plus 1. I distribute the numbers, combine like terms. If you can simplify, you simplify, but this one does not. So that would be my answer. And my last example for adding and subtracting has got a lot more going on. My denominator is x squared plus 3x minus 10, x minus 2, and x plus 5. I know when I factor now, I can factor this x squared plus 3x minus 10 into x plus 5 and x minus 2. So that means my least common denominator is going to be x plus 5 multiplied by x minus 2. So I've multiplied this first group by x plus 5, the second group by x minus 2. When I multiply, Notice I'm writing the x minus 5 here. It's minus x multiplied by x plus 5. So minus x multiplied by x plus 5. And then I have plus 1 times x minus 2. So plus 1 times x minus 2. No matter how many years I do math or how good I am at math, I always put that step there. Then I go ahead and distribute everything in my numerator. I combine like terms. And I write my excluded values. The last topic is going to be complex rational expressions, and it's putting division in a different format. And it's also possibility that you're going to have to do some adding and subtracting. So my first example is just 2x over 11 is the numerator, and then 6x over 55 is my denominator. I don't have any adding subtracting, so I don't need a least common denominator. So what this is saying is 2x over 11 divided by 6x over 55. It really is just a division problem. So when you divide, you take the second fraction, you flip it, and it becomes multiplication. I simplify like I did before, and I get down to the end. And I state my excluded value. Here's another one. Least common denominator is not needed. I just have a fraction divided by a fraction. So I flip the second fraction, well, excuse me, I rewrote it as a division problem. I flip the second fraction, and this time I factored the same time that I flipped. And you're welcome to shorten the steps any way that you feel comfortable. Just be careful when you do that, that you don't make mistakes. If I make mistakes, that's usually where I do it, is when I put two things in one step. I factored, I simplified, and I got my answer. This last one is a lot more involved, and this will be my last example for this video. So you can see I've got a fraction plus a fraction in the numerator, a fraction minus a fraction in the denominator. So I'm going to need least common denominators. And there's different ways to do it. This is the way I've chosen. I look for my least common denominator in just the numerator. So it's going to be 4 multiplied by x minus 3. I look for my least common denominator in my denominator here, and it's going to be 5 multiplied by x. So the first thing I do is I rewrite, this is my numerator. Notice I've used brackets divided by my denominator. I need to show that that goes together and that this goes together. And I'm not flipping anything yet because I have to have a full fraction. So I get my common denominator here, and I get my common denominator here. I work everything out like I did before, getting my common denominators, cleaning up the algebra. At this point now I have one whole fraction divided by this fraction. So now at this point I can flip this fraction and it becomes a multiplication. If anything simplifies, simplify it. If it doesn't, just go ahead and write all the factors in the numerator down, all the factors in the denominator, and then don't forget your excluded values.